So this is really why we're talking about significant figures at all. We often do calculations with measurements. And when we do calculations, the calculator often gives us numbers that have some truly insignificant digits in them. So when we do calculations, we need to round the result sometimes. Because what happens if you divide 2 by 3? 2 over 3, what is your calculator going to say? It's going to say 0.666666666. It's going to fill up the display with sixes. Well, if this was a rough measurement of 2 feet and we're dividing it into 3 pieces, is it really going to be 0.666, like 9 digits there? No. So how do we know what to do with these numbers that the calculator spits out? We have a set of rules to help us deal with the sig figs. Sometimes we have calculations involving multiple steps. We need to divide this by something, and we take that result, and we add something else to it, and then we do something else to it. And what's important is that we only round the final answer. So we're going to carry those extra significant figures. We're not going to round off at each individual step. Because if we round off at every single step, you're going to introduce error into your result. So there's 2 basic types of operations that we deal with. Multiplication and division are related to each other. In a way, they're opposites. And so there's one set of rules for dealing with significant figures in multiplication and division. So I'll read the rule to you here, but a lot of times when we put this in words, it doesn't make a lot of sense. But the result of multiplication or division carries the same number of significant figures as the factor with the fewest number of significant figures. So that probably doesn't make a whole lot of sense. So that's why we need examples. So here's an example. We've got 5.02 times 89.665 times 0.10. The calculator is going to show you this result. So applying the rules of significant figures, we're going to look at each of these numbers and identify how many sig figs. So 5.02, how many significant figures? 3. We've got 2 non-zero digits, and then we've got a trapped 0. So that has 3 sig figs. 89.665. That has 5. How about 0.10? 2. So this has a leading 0 that we don't count as a significant figure. The 1 and this trailing 0 is significant because of the decimal point. This is the easy part. 3, 5, and 2, which one's smaller? 2. So we identify how many sig figs in each of those numbers that we're multiplying or dividing. We figure out which one has the fewest, and that's how many sig figs our final answer will have. So we need to take this number, 45.01183, and round it to 2 digits. So we're going to keep the 4 and the 5. And then we're going to apply the regular rules of rounding. If the next digit is less than 5, we round down. If it's 5 or greater, we round up. So we're going to look at this 0 and say, oh, that's obviously less than 5. So we're going to report this answer as 45. Because 45.01183 is closer to 45 than 46. Any questions? Let's do another example. 5.892 divided by 6.10. Calculator gives you this mess. It's a division problem, so we're going to look at the first number. How many sig figs? 4. And 6.10, how many sig figs? 3. Which is smaller, 3 or 4? 3. So that means that our answer is going to have 3 significant figures. So we're going to keep this 9 and the 6 and the 5. 3 of them. And we look at the first one that we're getting rid of. It's a 9. That means we need to round this up. So this 5 is going to become a 6. And I'm going to record this as 0.966 with 3 significant figures. I put the 0 in there because it calls attention to the decimal point. Especially when you're writing things by hand, you make a decimal point with a sharp pencil and it can be really, really tiny, right? Hard to see. If you put a 0 in front of the decimal point, it says, look for decimal point, because why would we put a 0 in front? If this was the number 966, and I put a 0 in front of it, that would be weird, right? We just don't do stuff like that. So doing it like this calls attention. Any questions? This is something you're going to have to practice before it sinks in. So rounding, we're only going to look at the first digit that's being dropped, and we're going to ignore all the digits to the right of that. Let's go back to this example. So actually I can go this, there we go. So here I'm only looking at the first digit that's going to be dropped. Occasionally students, I don't know if they're trying to be thorough or what happens, but they'll start at the very end and they'll say, okay, well this is a 9, so this 3 rounds up to a 4, and that's less than 5, so that rounds this down to a 6. The 6 rounds that up to a 2, and they'll go all the way up like that. It's a waste of time and sometimes gets you the wrong answer. Anyway, just look at the first one. The rest of these are complete garbage. Complete garbage. So you round down if that digit you're dropping is 4 or less, round up if that digit being dropped is 5 or more, and we only round the final answer. Let's do a couple more examples. Perform each calculation to the correct number of significant figures. So if you have your calculator, get it out. So you do the whole calculation, and then it's a good practice to just write down what your calculator says before you look at the sig figs. So I've got 1.01 times 0.12 times 53.51 divided by 96 equals, and my calculator is saying 0.067556375. Anybody else get that? Okay. Because I always recommend that you do the calculation twice. If you get the same answer, you probably did it correctly. Now we're going to look at significant figures. This is multiplying and dividing, so we're going to apply the rule. How many sig figs in 1.01? 3. And in 0.12? 2. 53.51? 96? 2. So the smallest is 2, right? That means we round our answer to 2 significant figures. So what's that going to be? .068. The leading zeros don't count. Okay? They're just holding the decimal place. So 6 is our first significant figure, and 7 is the second one. So those are the 2 sig figs we're keeping, and 5 is the number we're dropping. 5 or greater rounds up, and so we round this to 0.068. Any questions? Questions are good, because usually if you have a question, there's like 3 or 4 other people in the class that have the exact same question, but they don't have the guts to ask. Let's do the next one. 56.55 times 0.920 divided by 34.2525. And calculator says 1.518896431. Anybody else get that? Okay. Now, do you have to write down these numbers of sig figs? No, you don't. After you practice a while, you'll be able to just look at these and determine which has the fewest. But for now, we're going to keep writing them down. 56.55, how many sig figs? 4. 0.920? 3, very good. And 34.2525? 6. That's not a 6. There we go. So 3 is the smallest. We're going to round this to 3. 1, 2, 3. The first one we're getting rid of is an 8. So we're going to write the answer as what? 1.52. Okay? This isn't really a complicated or hard thing to do. It's just new and different. And new and different can be hard to remember at first. Okay? But you're all capable of getting this. It's just you want to put in the effort needed to remember it. If you understand what we're doing here, then it'll be much easier to remember. Okay, so then the other type of calculation is addition and subtraction. So the result carries the same number of decimal places as the quantity carrying the fewest decimal places. Okay, so this is a little harder to understand from just the words, but it's actually easier to understand how this works. So let's look at these examples. We're stacking the numbers up like we were going to do the addition by hand without a calculator. But I'm going to go ahead and do the addition on my calculator. 5.74 plus 0.823 plus 2.651 equals, and I'm going to write the answer underneath, 9.214. And you see that the decimal points are all lined up. In the number 5.74, which digit is uncertain? 4, the last one. And in 0.823, which one's uncertain? The 3. And in 2.651, the 1. It's always the last digit that is uncertain. So when we're doing this addition here, we've got a 3 that we're not sure about, added to a 1 that we're not sure about. So we end up with a 4. Is that certain or uncertain? That's going to be uncertain. So I'm going to underline that one. And then let's look at the hundredths column. There's a 4 that we're not sure about, and a 2 that we're certain of, and a 5 that we're certain of. So when we get this result at the bottom, is that 1 certain or uncertain? It's going to be uncertain because of the 4. There was some uncertainty in the 4. It might have been a 3, it might have been a 5, we're not sure. So then when we get this result, we can't be sure of that digit either. There's a certain 7, a certain 8, a certain 6. Are we certain about that too? Yes. Yeah, we are. And we're going to be certain about everything to the left of that. In numbers, when we record them, we include 1 uncertain digit. So then we should report this as 9.21, and we're going to drop the 4. There's uncertainty in the 1. The next digit doesn't matter at all. So that's one way to look at it. Any questions? Another way you can look at this, let's see, maybe that color, is to take this stacked example and find the number that stops first. So this one stops in the second decimal place, and these other two go on. And so I'm just going to draw a line to the right of that one. So that top number stops first. It stops in the second decimal place, and so I'm just going to draw a line. And that line is where my number is going to stop for my final answer. That's where I'm going to round it off. So that's 2 different ways of figuring it out. These both follow this rule. The same number of decimal places as the quantity quantity with the fewest. This number has 2 decimal places, this one has 3, and this one has 3. And so our final answer is going to have 2 decimal places. This rule is different than for multiplication and division. It's not the number of significant figures, it's the number of decimal places. Let's look at this one. 4.8 minus 3.965. Well, the first thing is just do it on your calculator and write the answer. So 0.835. That's what the calculator says. How should I report that answer with the correct number of significant figures? Oops, that's a negative. No, it isn't. 0.8. This number stops in the first, after the first decimal place. So I could draw a line there. And that means that this is the last digit I'm going to keep. I can also look at the uncertain digit and see that this digit's uncertain and this one's uncertain. If there's uncertainty in the tenths place in one of these numbers that we're adding or subtracting, then there's going to be uncertainty in the tenths place of the answer. And we're going to stop at the first digit that has uncertainty, because what comes after that is meaningless. It doesn't matter at all. And in this one, we can see that the rules for multiplication and division can't work for adding and subtracting, because this had 2 sig figs, this has 4 sig figs, and this ended up having how many? Just 1. So you can end up with a number from adding subtracting that doesn't have the same number of significant figures as anything that you started with. Weird things can happen. Any questions? So here's 2 more examples. This is how we normally see problems, not stacked up like that, but horizontally. So the first thing is to just do the math on your calculator. And write down the answer. Oops. I'm getting 7.588. Anybody else get that? Okay. How should I round this? Well, first thing is, what's the last, where's the uncertain digit? So this one has 2 decimal places, 3 decimal places, 4 decimal places, 1 decimal place. So I'm going to have 1 decimal place in this one. I'm going to keep the 5. And so I'm going to round this up and call it 7.6. Any questions? Yes? This is adding and subtracting, and so instead of looking at the number of sig figs, we're looking at the number of decimal places. So this has 2 decimal places, this has 3 decimal places, this has 4, and this one only has 1. Another way to look at it is to look at the uncertainty. So this has uncertainty in the hundredths place. So we could say that this is plus or minus 0.01. This has uncertainty in the thousandths place, plus or minus 0.001. This has uncertainty 0.0001. And this one has uncertainty of plus or minus 0.1. Because that is a measurement with uncertainty in the tenths place. The 8 is uncertain, could be a 7, could be a 9. That's what plus or minus. It might be plus 0.1, might be minus 0.1. And so which of these uncertainties is the largest? 0.1 is the biggest, right? And so then our answer is going to have an uncertainty equal to that, plus or minus 0.1. So it's rounded to the 10th place. Anybody still have questions about that example?
Could you still use just the number of sig figs you find?
No, you can't. Sometimes it'll end up being correct.
Like, because this one, because that's what I did with this one.
Sometimes it works, and that's what's really tricky about it, because you think, oh, well, yeah, that works. I like that rule better. But like on this previous example, with this one, it didn't work. Because this ended up with 1 sig fig, and neither of these has 1 sig fig. And so it just does not work with adding, subtracting. Any other questions? Let's do this one. 7.876 minus 0.56 plus 123.792. Calculator says 131.108. So this one has how many decimal places? 3. And this one has 2 decimal places, and this one has 3. So that means we're going to round our answer to 2 decimal places. So we'll call this 131.11. And that's another example where the multiplying dividing rules don't work. This has 4 sig figs, 2 sig figs, 6 sig figs, and this one ends up with 5. This doesn't work. Sig figs are a topic that a lot of beginning chemistry students don't enjoy. And that's fine. You don't have to like everything. But the alternative is using differential calculus to keep track of this. You want to learn that? No, I didn't think so. And I don't want to teach it to you either, because I learned that when I was in college and then I promptly forgot it. I could figure it out again, but I don't use that on a daily basis. Significant figures, although they seem pretty confusing at first, are actually a pretty straightforward and quick way of keeping track of our results and how the significance is, where the uncertainty is. So we just did that one. Okay, what if you have multiplying, dividing, and addition or subtraction all mixed up in one problem? Then things get really fun. Let's see. Please, there's that order of operations. Have you heard this one? Please excuse my dear Aunt Sally. Have you heard that one? Yeah, so parentheses, exponents, multiplying, dividing, addition, subtraction. That's the order of operation. So we need to do steps in parentheses first. We need to look at addition, subtraction, multiplication, division separately in terms of the significant figures. So we're going to have to look at intermediate values, do the remaining steps, round the final answer. So let's see how that works out. So here we have a problem that mixes multiplying and subtracting. The subtraction is in parentheses, and so that happens first, and then we multiply. I prefer to just do the math, write down what the calculator says, and then we'll look at what's going on with the sig figs. So 782.3 minus 451.88 equals times 3.897 equals. And the calculator says 1287.64674. We can't just look at the number of decimal places or look at the number of sig figs of those three numbers that we were multiplying and subtracting and figure this out. We have to look at those steps individually. We have to look at the result of this subtraction first. So 782.3, I know we're duplicating our efforts here, but it's a little more straightforward this way. So the result of that is 330.42. We're not going to round that off, but we're going to identify the sig figs in that number. This is subtracting, right? So this has one decimal place, this has two decimal places. The result of the subtraction should have how many decimal places? 1. So I'm going to underline that digit. That's what we've been doing with our uncertain digit at the end. But I'm not going to round it off. Then when I take this number and multiply it by this number, I'm going to apply the multiplication rules to figure out how many significant figures. How many sig figs does 330.4 have? It has 4 sig figs. We're carrying the 2 around because we don't want to have rounding errors, but it's not a significant figure. And how many sig figs does 3.87 have? Also has 4. So then our final answer should have how many significant figures? 4. So now we're going to round our answer. We're going to keep the 1, the 2, the 8, and the 7. And this is the one we're getting rid of. So we're going to call this 1,288.
When you multiply the first part by the second part, you multiply with what you added.
Yeah, you don't want to take this and round it to 330.4 and then do the multiplication. You want to carry everything along till the very end. Yes?
What was the abbreviation in the previous slide again?
Please excuse my dear Aunt Sally. Please excuse my dear Aunt Sally. Please excuse my dear Aunt Sally. Exponents. Any other questions? Let's do another one. So on this one, we're going to do the division in parentheses first. 4.58 divided by 1.239. I'm going to press equals. Now, if you want to, you could write this down so you don't have to come back and look at it again later. The result of that is 3.696529459. If that was my final answer, how many sig figs should it have? 3. This one has 3, and this one has 4. This is division. So we're just counting sig figs, not looking at decimal places. So this has 4 sig figs. So that would be 3, 6, 9, and 6. That would be the last significant figure. Don't round it off. You don't have to type it back into your calculator again because it's already in there. Now subtract. Subtract 0.578 and write down the whole answer, 3.118 529459. Now we're going to compare this number and that number, because those were the numbers that got subtracted, right? So now we're looking at decimal places. So I'm going to just cross that off. This has how many decimal places? 3. I underlined the last significant figure. This has 3 decimal places. And how many does this one have? 3. So then my answer should have 3 decimal places. So there's the 3rd decimal place. The first digit I'm getting rid of is the 5, so I'll round this up and call it 3.119. Any questions? Yes?
I don't want the 6 or the 9 on the first. It would be the 9 I would raise
I made a mistake. Thank you. Back up. Wouldn't it be great if we could do that in life? Oh, I don't want to do that. Okay. Yes, I made a boo-boo. 3 sig figs, 4 sig figs, 3 is smaller. So it needs to be the 9, which changes things, doesn't it? Because this now has 2 decimal places, this has 3 decimal places. So our answer should only have 2 decimal places. So it's 3.12. Thank you for pointing that out. I find it very helpful to write down the whole long thing that my calculator gives me, because then if I realize I made a mistake in my rounding, I don't have to do the calculation over again. And that just happened, didn't it? We realized, oops, she rounded it wrong. Didn't have to do the calculation again. I just went back and fixed the number of significant figures. Another thing to remember when you're doing stuff like this is it's better to carry too many digits than not enough. Sometimes students get a little carried away with rounding and they round everything off to 1 sig fig and they do all kinds of funny things. It's better to keep too many because you can always round them off after the fact. But if you've rounded too much, then you have to do the whole calculation over again to get the answers back. Any other questions?